Write the truth table of the logic gates marked P and Q in the given circuit. Here if you are going to observe the P, there is P circuit which gives the information related to the NOT gate. NOT gate, we know that it is the reciprocal. That means if I give the input A as a 0, it gives the output as 1. If I give the input as 1, it gives the output as 0. Okay, this is P. And Q, it is the NOR gate. Q, it is the NOR gate. Okay. Okay, it is the negative portion of the OR gate. That means if A, B is the input and Y is the output, that means if anyone is high in this circuit, then it becomes a 0. That means with 0, 0, which gives the output is 1, because no one is high here. If 0, 1, it becomes 0. If 1, 0, this becomes 0. If 1, 1, then it becomes 0. This is the condition case of the NOR gate. And the exam means this is the solution for the first case, that is A. Second one, write the truth table for the circuit. Okay, for this one, if I want to write the truth table, then it looks like this. Okay, example, B case here. If I take the A and B and the output is Y, A is the, that is the NOR gate. That means if the NOR gate condition is equal to 0, then the output becomes 1. If 1 is there in the NOR gate, then that becomes 0. Then 0 and 0, NOR gate becomes 0. Okay. And if 0 is there, then it becomes 1. If 1 is there in the NOR gate, it becomes 0. If 1 is there in the NOT gate, then the output will become 0. If 0 and 0, that becomes 1. If 1 is there in the NOT gate, it becomes 0. If 0 will becomes 1, then 1 and 1 will becomes 0 in the NOT gate. Okay, this way we are going to write the truth table for the given circuit. Second, why are the NOR gates considered as the universal gates? NOR gates considered as the universal gates because all basic logic gates can be solved with the help of the NOR gates. All basic logical gates can be realized by the using the NOR gates. Next, okay. Second condition here, explain how a potential barrier is developed in a PN junction diode. Okay, the PN junction diode, here the two semiconductors are there. It's a P semiconductor and here the N semiconductor. Usually the P semiconductor is connected to the negative terminal and the N side is connected to the positive terminal. Okay, well, see the explanation part. During the formation of the PN junction diode, due to the concentration gradient across the P and N side of the diode, holes diffuse from P side to N side and electrons diffuses from N side to P side, giving rise to development of immobile positive charge on the N side and the negative charge on the P side across the junction. Thus, a potential barrier is formed at this junction. In this way, a potential barrier is developed in a PN junction diode. Next, draw the circuit arrangement for studying the VI characteristics of a PN junction diode. In reverse bias, plot the VI characteristics in this case. Okay, see this is the PI junction diode. So this is the PN junction. Okay, and this is connected to a voltmeter, and again it is connected to the P junction. It is connected to the negative terminal, and the N junction is connected to the positive terminal. And if it was micrometer, they are going to check here. This is circuit arrangement of the PN junction, and the VI characteristic in this case is like this. Okay, Since it is a reverse bias, okay, when means when it is of action, means it starts from negative values, it is gradually increases, and when the breakdown points will come, then it gradually increases like this. This is the VA characteristics of the PI junction type in reverse bias.
This is right.